Hello, Professor, and everyone who watching this video. So today we are going to introduce the another energy storage systems, magnetically confined kinetic energy storage ring by using effective limitation or MCKESR. My name is Nathanan and here is Lada. So let's introduce the history of MCKESR. So first, at 1984, the first presentation of this concept have been reported. After that, 1 year, Hall and Searhurst have presented this concept in IECEC conference. And after that, in 1984, Hall, Lloyd, and Brooks have defined the concept of MCKESR in IEEE Winter Meeting Conversions.
The importance of these energy storage systems. MCKESR is a new type of energy storage systems that store the kinetic energy by circulating the mass at a high speed velocity. So the importance is about balance the electric supply demand in real time to store energy from the renewable source and provide backup power for the grid scale, also improve and enhance energy efficiency.
So how does it work? At the charge process, the electrical energy from the grid has fed a cycle converter. As you can see at the green arrows, the electric energy will input here. Next step, the cycle converter will power up the stationary copper coil at the blue yellows in the right pictures. So after that, the interaction between the magnetic and the permanent magnet will accelerating the links. So after link have high velocity, it will store the kinetic energy. So the next is about the formula of the charge process.
So after knowing the charging process is by converting electrical energy into kinetic energy, I would like to elaborate more on the interactions between the input-outer coils. So for the cycle converter feeds the process electrical current to the stationary copper coils located near the inner radius of the ring. These coils generate a magnetic field. So for which introduced us to our first formula, which is the force exerted on permanent magnetic. So the magnetic field produced by the stationary coils interacts with the permanent magnets embedded in the inner part of the rotating ring. This interaction exerts a force on the permanent magnets, while the exact formula for this force due to the input output coils isn't explicitly stated in the simplified forms in the sources. The general principle of force on a magnetic dipole in a magnetic field applies. So a related concept is the force exerted on a unit volume of magnetic material by an external magnetic field, given by F equal to delta of M, which is the magnetic polarization of the permanent magnets or the ring material, and B is the magnetic induction field generated by the inner outer coils. This force has a component and also divided by permeability of free space, which is a constant. So this force, the F, has a component in the tangential direction causing acceleration. So this acceleration of the ring is the tangential force on permanent magnets causes the ring to accelerate, increases its rotational speed, which creates kinetic energy. This acceleration directly increases the velocity of the ring, as well as the relationship between the forces and the ring's motion is governed by the Newton's law of motion. Okay. So let's move on to the PC first, which is the magnetic pressure, in order for us to go and find the stored kinetic energy or the velocity as well. So PC is the magnetic pressure, so which is equal to M2 B2 minus M1 B1 divided by permeability of free space. So the subscript 1 and 2 denotes the inner and outer ring surfaces. Okay, so now that we have this, we can now calculate the stored kinetic energy and as well as the velocity, since we give them electricity in order for us to gain kinetic energy. So the stored kinetic energy is as such, which is equal to pi PC from the previous formula, multiplied by z, which is the height of the ring's cross section, and r squared, r, which is a MCKESR radius. Okay, so for further formula and clarification, there is also the the ring's velocity achieved through the IO system directly leads to a gradient stored for a ring mass. So the formula is as such, which is PC divided by mu, which is the normalized density of the ring, multiplied by the width of the ring's cross section, square root, and divided by r.
Okay, next for discharge process, the energy of the rotated rings will convert back into the electrical energies, so it's a reverse system of the process. So the spinning rings will move toward the stationary pickup coil, and it will include the electric current. The current will flow out the output lead as the orange arrows in the pictures. So the lead will carry the output electricity to a power condition systems, which is a grid or the load of the system. So next is the formula of the discharge process.
Okay, so like Natana stated, this discharging process is converting kinetic energy to electrical energy. So the process begins with the rotating ring possessing a significant amount of kinetic energy, which is from before we have calculated the stored amount of kinetic energy. And as the ring rotates, the permanent magnets embedded in it move past the stationary copper coils. So moving on, the movement of magnetic field from the permanent magnets across the stationary copper coils induces a voltage V loop in these coils. According to Faraday's law of induction, the maximum possible voltage in a pickup loop is approximated by a V loop, which is estimatedly equal to Bm, which is the magnetic induction in the gap produced by the permanent magnets multiplied by Wm, which is the width of the permanent magnets, and multiplied by V, the velocity of the ring, which is calculated from the formulas before since it's the initial. Moving on to the next one. So I would like for you to also know that the induced voltage drives a current in the coils. Like, so the electrical current generated in the stationary coils is fed into the cycle converter. In the discharging mode, the cycle converter acts to convert the variable frequency AC power generated by the MCKESR back into the grid frequency AC power suitable for the utility grid. So, which leads us to our next equation, which is the power output. The electrical power fed back to the grid is related to the induced voltage and current in the pickup coils, as well as the design of the input-output system. A formula for the output power can be considered as such. So PIO, which is equal to V loop from the left formula, and multiplied by I, which is the current in the coils, multiplied by NC, which is the total number of pickup coils, and multiplied by number of N, which is the number of loops in each coil, and also multiplied by the E, which is the effectiveness of each coil. So for the discharging, there is, of course, a decrease in the stored kinetic energy. So as electrical energy is extracted from the system, the rotational speed and thus the kinetic energy of the ring decreases. The process continues cyclically for energy storage to storage and release energy. The efficiency of the conversion is affected by various losses within the system, such as resistive losses and the copper coils, as well as hysteresis and eddy current losses in the ring material, and as well as the efficiency of the cycle converted, which is omitted for this study. Moving on to our last section, which is our application. So while the paper or this energy storage system primarily focuses on diurnal load level for utilities, which is handling the daily fluctuations, the peak and the lows of the load demand. The characteristics of the MCKESR suggest potential applications in modern power systems. Its ability to store and release large amount of energy could be valuable for smart grid, providing a grid scale energy storage for frequency regulation, as well as voltage support and overall grid stability. The rapid response capabilities of magnetic systems could be beneficial for managing fluctuations in demand and supply within a smart grid environment. Secondly is microgrid, enabling great autonomy and reliability for microgrids by providing a significant energy buffer. This could help integrate distributed generation sources and ensure power availability during outages from the main grid. And third and lastly, which is the renewable energy systems, the MCKESR helps mitigate the intermittency of renewable energy sources like solar and wind power. Not only that, but it could also store excess energy generated during peak production periods and release it when generation is low, thereby smoothing out the power output and enhancing the reliability of renewable energy in integration into the grid. So thank you very much for listening to us as we introduce to you to another energy storage system, which is MCKESR, or abbreviated from magnetically confined kinetic energy storage rings using attractive levitation, which can charge by converting electrical energy to kinetic and has a more kinetic energy stored, and then discharging by releasing the kinetic energy into a greater output of electrical energy. So thank you very much for listening to us.